Hello guys, today I want to cover this problem. It's problem 3 from IB Chemistry HL exam, paper 2. It was last year's November session, and let's start. So the first thing we need to do is to write the ground state configuration for iron plus 2 and iron in state 0 is 4s2,3d6 and it lost 2 electrons. So we can just cancel these electrons, and what we will get is basically argon and 3d6. Now we need to show how a relative atomic mass can be obtained, and we can see that percentage of copper 63 is around 69%, and copper 65 is around 31%, and relative atomic mass, it's basically the weighted sum of all masses. So it's going to be 0.69 times 63 plus 0.31 times 65, and we will get 63, 62, the same number as this one. So this is right calculation. For the next question, we need to predict who has greater ionization energy. And the simplest we can explain it's this copper have the same number of protons as this copper, same proton number, but this copper have more electrons. So when we keep reducing the number of electrons from the nucleus, it's going to be harder to reduce number of electrons more, because the number of protons is the same, but the ratio of protons divided by electrons, it's gonna keep increasing, and the nucleus is gonna keep pull electrons stronger because there are less electrons. And the ionization energy is basically energy required to remove one electron from the shell, right? One electron. So this is why the ionization energy keeps increasing with the number of electrons we are trying to remove, right? For the next, we need to determine the frequency of the light, and we can use this formula, but I will slightly modify it and multiply by Avogadro constant, because this formula is energy of one photon, but this formula is energy of 1 mole of photons, and it's going to be easier to do calculations, because ionization energy and every energy that we are given is for 1 mole of something. So in this case, it's plus 745 kilojoules per mole, the first ionization energy of copper. So the frequency is equal to energy divided by Planck's constant times Avogadro constant, and we need to just plug in numbers. Don't forget that we need to use joules instead of kilojoules. And this is going to give us around 187 times 10 to the 15 power per second. And if we want to calculate the length of this photon, we can just use this property. This is the length, and the first one is the frequency. For the next question, we need to outline the magnetic properties. Let's just draw the orbitals of iron. So this is 4s level, and this is 3d level, it has 5 orbitals and there are 6 electrons, so we need to split them like this. And we can see there are 4 unpaired electrons, and because it has more than 0 unpaired electrons, this is going to be paramagnetic, so it aligns with magnetic field. It have magnetic properties. But interesting, if for example we will use some complex of iron plus 2 just to remove those electrons, right? For example, this complex. Right here. So by the crystal field theory, it's octahedral complex and it has 6 electrons and it's low spin complex because this is a strong field ligand and the energy to jump from the lower energy orbitals to higher one is pretty significant. It's gonna split our orbitals like this in ratio 3 to 2, and our electrons would look like this because this energy is pretty significant. And this complex would be actually diamagnetic. So it would not align with magnetic field. Unlike iron in ground state, which have 4 unpaired electrons. But for example, if it's a weak field ligand, for example, like this, then it will be paramagnetic again, and our electrons would look like this. And we will get the same 4 unpaired electrons, and it will be paramagnetic, which is kind of interesting property that I wanted to remind you. For the next, we need to label the diagram and write the half equations. We can see that copper is reduced to oxidation number 0, and this is going to be cathode. I know they don't ask for the half reaction on the cathode, but it's just going to be useful. And iron is oxidized from oxidation number 0 to +2. So our reaction for anode would look like this, and this is what they are asking. So this is going to be our iron electrode. We will get iron +2 in the anode solution around the anode. Our cathode would be copper, and our ions around the cathode would be copper +2. And for the next question, we need to explain the function of the thought bridge. Basically, for example, let's look at anode. We can see that there forms iron +2 cations, but we need to keep our solution electrically neutral. So from the thought bridge, there need to come like nitrate ion. So this solution would be neutral. And if we look at cathode, the number of copper +2 ions is decreasing because it's reduced to copper with oxidation number 0. So from the thought bridge, we will get our potassium cations to compensate for this copper. So basically, the function of the thought bridge is just to keep our electrolyte solutions neutral. Predict the movement of all ionic species through the thought bridge. As I said, there are only nitrate ions that are negatively charged, but we have one trick, is that we need to specify all ionic species, and if we look closely at our cell, in this solution we have iron +2. So some part of this iron is gonna move through the thought bridge to the cathode solution. So this is pretty obvious, but for the cathode we will get not only potassium plus, but also iron 2 plus. For the next we need to find the standard cell potential, and our standard cell potential would be potential of the cathode minus the potential of anode. The potential of cathode is 0.34 and the potential of anode is minus 0.45. Our answer would be 0.79 volts. The last question, we need to find the standard free energy change. We can just use this formula. The number of electrons is 2. Because we are reducing copper plus 2 to copper 0, there is 2 electron change, and the same goes for the iron from 0 to plus 2. F is the constant, Faraday's constant, and the cell potential is minus 0.79, and we need to just plug in some numbers. And this is equal to 152.4 kilojoules. I hope you enjoyed my solution. I would like to hear your thoughts on this problem in the comments. Thanks for watching and see you next time.